The views and opinions expressed on Coffee and Compatibility are those of the podcast host and do not necessarily reflect the official policy or position of ASHI.
Welcome, everyone, to another episode of Coffee and Compatibility. With me, as always, is Madam President-elect Dr. Kelly Hitchman.
Aw, I'm blushing. Thanks.
And Jeremy Sherrill, not to be forgotten.
Or outdone.
Hey, everyone.
So congratulations. Very much well-deserved, ma'am.
Oh, gosh, thank you. I am super excited to serve in any capacity for such a wonderful society, but it's beyond the honor of a career time to get the chance to serve your society in that way, as Dr. Halpin is learning right off the bat. So I think I'm excited to serve between the Dr. Murphy and Dr. Halpin sandwich that I am so fortunate to be a part of.
Can we play Hail to the Chief? Can we play Hail to the Chief on the podcast from here on out?
Absolutely not.
we definitely. So everyone knows this is totally unplanned. I did not tell Kelly that I was going to do that, so she's totally caught off guard because I had to do something to embarrass the Madam President-elect.
It's so easy. It's so easy. Let's talk about something else.
The ASHI meeting.
Anything else, like the fantastic ASHI meeting.
Oh, okay, that was awesome.
Kudos to Dr. Luis Hidalgo and the entire ASHI program planning committee. What an outstanding meeting. What a balanced meeting. What like a thought-provoking content. There did seem to be like this AI theme, which featured a lot of our very own Dr. Weimer, and it was awesome. I mean, that is something that I am so deficient in, but it's really just not an option anymore. We all need to learn a little programming. We all need to learn, some of these skills. So thank goodness ASHI has different ways of helping people get in touch with those. And the annual meeting was that this year. It really helped me get in touch with some resources. Yeah. What about you, Eric and Jeremy? What'd you like about the annual meeting?
Go ahead, man.
Well, for me, it was really good to see everyone's experience with there's a big change going on, a big shift in HLA typing expectations for deceased donors. And so working for an OPO, that was great for me to see how nanopore sequencing is working for people who've implemented it. We're looking at implementing it at our lab very soon. And so it was a lot of great information and education there. And it was great to see everyone. It's always great fun. So
yeah, I think
and I set a goal for next year. Next year I am going to do the Halifaster Tulip Run. It's going to be the inaugural Halifaster Tulip Run. It's the same as the regular Tulip Run. It's just half as long.
It's Halifaster.
If anyone would like to join me in that, we're going to do the Halifaster Tulip Run.
We need to brand that.
Like speed walking? Is speed walking a thing? Cardio and I just don't get along.
Cardio. I really like the annual meeting from the perspective of, I think it's incredibly hard to balance the basic science that we all want with the clinical, practical application that many of our members also want. And I think this particular meeting did a very good job of sort of walking that tightrope to balance the things that are upcoming and the things that were impact the day-to-day operations. So very, very well done.
I think, next year we'll be in Montreal in Canada, and I am so excited for that meeting. Not to mention, folks, we just got done with the ASHI annual meeting, but it is never too soon to start talking about the next. And the next meeting, Dr. Kathy Murphy will be at the helm. I'm sure she is putting together a great program planning committee as we speak. She's got such a depth of knowledge. She's got so much charisma, so much chutzpah. I cannot wait to see a Kathy Murphy program planning committee meeting. And I can't wait to see Montreal. So I think it's going to be a lot of great science. And so kind of put that on your radar as well. I heard that we got some really good feedback from folks recently and regarding how to access our podcast and different ways in which they would like to access our podcast. And Jeremy had some good ideas about that. You wanna let our folks in on the good stuff?
Yeah, sure. So you of course can listen to our podcast on a number of different platforms, but if you're listening on YouTube, you'll want to make sure to tune in on our YouTube channel and subscribe. And if you're listening on YouTube, then you can actually utilize a tool within YouTube to generate auto-generate captions in whatever language you like. I don't know how many languages they have, but I was looking the other day. It's a lot. It's a lot of languages. And so there will be details about how you can use that auto caption tool on the YouTube channel. It'll be in the information below our video today.
Yes, and I want to share with everybody out there that Jeremy was sharing with me that there are many languages available. So if you want to listen to us in Espanol, you can do that. And apparently, if you want to listen to us in Dothraki, that is apparently true. And my immediate response to that was, like, does it sound like Jason Momoa? Because I'll listen to it in Dothraki if it sounds like Jason Momoa.
I mean, I will
Also,
too. So let's do this
right?
thing.
Like, who doesn't want to hear that? And
Also
no matter
Klingon.
how, you're right. Oh, let me skip that one. I've got enough wrinkles on my forehead. I do want to say, however you listen to us, and don't just listen to us, hit subscribe. The more you subscribe, the more reach we have in the algorithms, in the stratosphere of the internets. So please don't leave us hanging. Subscribe to us on ASHI HLA YouTube channel. We would so very much appreciate it. And stay with us because we're going to be right back after a short break. And today we are talking about drones.
Human Immunology is the official journal of the American Society for Histocompatibility and Immunogenetics, published by Elsevier and led by the current editor-in-chief, Professor James Matthew from Northwestern University in Chicago. Since its launch in 1980, Human Immunology has published more than 6,000 articles covering immunogenetics, transplantation, immunology, autoimmunity, and immunity to infectious diseases in humans. The impact of human immunology is evidenced by more than 146,000 citations accrued by the publication, which have been downloaded over 4 million times. Join our community of authors and share your discoveries with a global audience. Visit sciencedirect.com/journal/human-immunology to find out how to submit your research.
Welcome, everybody. Today on Coffee and Compatibility, we are so excited to welcome Kevin Myer, President and CEO of LifeGift, a Houston-based organ procurement organization where he has been driving innovation in organ and tissue donation for over 35 years. His leadership extends across 240 hospitals and 9 transplant centers in Texas. And in 2021, he was appointed chair of the Organ Donation and Transplantation Alliance Board, which completely reflects his impact on advancing the field. We are so grateful to have you with us today. Can we call you Kevin?
Absolutely.
Awesome. Awesome. Thanks for being with us. You know, I will say that I have been so fortunate to get to bump into Kevin at a Texas Transplant Society meeting and at various transplantations meetings here and there. And there is a topic that we really wanted to ask you about, Kevin, today, because it's something that kind of it comes up and we hear a lot about it, and then we don't hear anything about it for a while, and then it comes up again, and then we don't. So the topic du jour is drones in organ allocation. And maybe that's not all that we'll talk about today.
Sure.
But can you tell us, at least from your purview and any projects that you've worked on, when did this idea of using drones to transport, be it organs or samples or whatnot. How did this whole idea get started?
Yeah, great question. And thanks for having me on. It's just a real honor. I just was so surprised when you guys asked me to chat with you. So yeah, so the whole drone topic, it's been bantered around for years in the organ transplant, of course, the healthcare sectors for a while. So this really got started for us in 21-ish out in West Texas, so out towards Lubbock in Amarillo with Texas Tech. And the rural healthcare situation and challenges there are significant. In fact, many patients who have end-stage renal disease, just don't even bother to be listed for kidney transplant because of the distances. And that was sort of the environmental approach. We provide services out in West Texas in Lubbock and Amarillo. And again, working along with Texas Tech and some other groups, To the Edge, innovation groups, and some experts in drone technology, we kind of had this notion that drones may be a really nice adjunct to helping with moving kidneys, and before that, actual samples to help overcome some of those geographic barriers. So we joined up with the innovation group at Texas Tech and with the University Health Sciences Center there and others in the drone space to conceptualize this, and it got turned into this project called Project Matador.
So is this actually being used? Is it still in like experimental phases? And I guess to make it a complex multi-part question,
Sure.
like what are these drones like? Like in my head,
Yeah.
and maybe in the heads of some of our listeners, we're thinking of like these little like toy drone things, but I have seen these things and I know that is not what they are. So maybe if you could kind of describe what they look like for
Sure.
everybody too.
Yeah, yeah. So these are not the drones you buy at, Best Buy. These are heavy duty industrial level drones. They're not military grade. What's really interesting about all of this, these types of devices have been used, or aircraft have been used in developing countries in various areas of Africa for a decade. And we're talking thousands and thousands of missions to move, blood, to move antivenom, to help out with, public health or emergency medical services types of things. The ones in Africa that also we've tested in West Texas, they have about 100 mile range, and they can carry a payload. These typical ones can carry a payload of probably 10 pounds. So they're not huge, but we're also working on some pretty huge ones to potentially use. So that's that piece. The they're not actually in the organ transplant space being commercially used yet, but we're close. And actually, we think a lot about, we jump to the conclusion that, to overcome the allocation challenges for moving kidneys, that's sort of what we think is the first use case. The first use case is moving blood samples. So let's get into the rural space, right? And this is very germane to our friends at Ashley, like everything's about the samples, right? So you think about the geographic distances in eastern New Mexico and western Texas. And actually there's a new kidney transplant program that just got started up that we helped get started at at Texas Tech and Covenant Health Sciences. So that's our 10th transplant center. It's kidney only. But so you have patients that are 6 hours away. You guys are experts in the requirements for immune monitoring and, workups and things like that. People really do not want to get listed. They don't want to drive 6 hours. So the notion is, let's use drones as a bridge to moving these samples. So in the rural community, there certainly has to be a clinic or a fire station where there's a paramedic who could draw blood. And so the samples get mailed to them, draw blood, collect the samples, and load them up on a drone. The drone goes out there, drone flies it into Lubbock, and it goes into the lab situation like that. So that is the easiest use case because the weight of that is minimal, and it really helps overcome a geographic challenge. So that's that. We did do testing together. So our friends at TOSA and our friends at STA and also Oklahoma, along with To the Edge Innovation, which now is called Valkyrie, and Texas Tech and a bunch of people, we used research organs to test long-range movement of organs and monitor for vibration and, all the environmental parameters. And this drone actually was basically the size of a Cessna, and so the idea is that it's an autonomous vehicle. And so we still had a pilot in the plane just for safety reasons, but it was flown as an autonomous vehicle with a research liver, research pancreas, research kidneys. And we started in Lubbock. We flew all the way to San Antonio. And then from San Antonio all the way back up to Oklahoma City. And then from Oklahoma City all the way back to Lubbock. So it was an all-day event, but we had a whole team, we had, all kinds of people there to help check it out. And so that was successful. And it demonstrated that you could do long-range movement safely.
So Kevin, right now we're talking about samples, but it sounds like in the future, there's the potential to use this not just for samples, but for the organs themselves.
Mm-hmm.
What about say just transporting a kidney on a pump?
Mm-hmm.
Right? Would it be feasible to use these at some point in the future to transport organs along with whatever type of perfusion device
Mm-hmm.
is being used in that case? Would that be feasible?
Yeah, that's definitely feasible, and that's where you need to get to the larger drones that have more lift because of the weight of at least currently, the weight of the kidney perfusion device, and that's being worked on in multiple sectors. Various groups are helping to fund some of that work. So that is definitely conceptualized, and there is work being done on that. And what's really also interesting that fits in with that is dealing with, of course, the important regulations the FAA has, and that's been one of the barriers, but we're getting there. And so you think about so this is one of the areas that most people don't realize is that most of the larger railroad companies, and of course here in Texas, it's BNSF, and they've been great partners. They've been running, and this is where the concept was actually originally conceptualized. They've been running drones over the railroad tracks twice a day for years for track integrity and security reasons. The FAA has already approved those pathways. So you have to think about a roadmap. And of course, guess where, railroad hubs are? They're in generally larger cities, especially when you look at, or you put that into the geographic situation of where we are in West Texas and so forth, and where we send kidneys towards Colorado or Arizona or back into, Dallas or who knows where. But the railroad tracks all go there. And so the idea was that this is one of those light bulb moments. I'm not kidding you. Sitting in the Fort Worth office that we have, one of the BNSF railroad tracks goes right by our office. Like you can walk there in 25 or 50 feet. And we hear about this from some other experts we are working with. And we're like, wait a minute. You have a drone that goes by our office in Fort Worth twice a day? Can we hitch a ride? That's where it came from. And that was the genesis of the original idea. Now, there's an expansion of this happening very quickly. So our friends at Mid-America Transplant in St. Louis have funded this same group to look at moving samples from their main office in they have two main hubs. So the main office in St. Louis, and then I forgot the name of the city that's further up. But currently they use a King Air to move those blood samples from the other location that they have, to get it into their central lab. And that's super expensive. So they've conceptualized and funded doing this. I think they actually will be the first to really sort of commercialize this. And as you well know, there's a lot of work going on in the background about getting funding, or approval for funding or reimbursable funding for Medicare, CMS, et cetera, et cetera. Certainly the patients will benefit from this, the system will benefit. And I think you guys, doing the hard work of all the matching and cross-matching and immune monitoring will benefit really, really nicely from this. And that's one of our biggest hopes.
Kevin, I think this is super fascinating, right? And one of the things this brings to mind is two things. Is one, who's actually flying these drones? And two, sort of what you were just touching on in that, like, I think the drone technology represents not only a major step forward for how we can deliver organs and samples, but also how we can track where they are in sort of a more, we'll say, modern approach in there. And so I'm wondering your thoughts on those two specific topics.
Okay. Yeah, that's a great question. Like, where are these being flown from? So what is critical? So most of the FAA regulations still require drone use, like in this particular space, to be visual line. You have to have eyes on the drone, right? This is moving beyond that. This is beyond visual line of sight. And so, for example, I mentioned the track integrity stuff. There's a bank, if you will, of drone operators, pilots, very similar to what the military has. And in fact, many of the pilots are former military service members. Or just envision, if you have any, now it's not even teenagers, 10-year-olds at home, doing the stuff with all that, the computer games. But anyhow, that's how they're piloted. And so they're monitored and tracked and so forth by experts who, are trained in that. There's all kinds of requirements for that and so forth. But yeah, they're all not autonomous, but they're piloted from a geographic, distance, and it's not line of sight. It's fascinating. And so, that is a great idea, a great opportunity. And then the tracking, of course, like any type of aircraft in the public airspace, it's so important. And so one of the things you learn about all this stuff, if you're a pilot, I'm not a pilot, but I did learn that you have to learn, if you're not a pilot, you think in sort of two dimensions, right? And, people who are drone people are thinking, in 3 or 4 dimensions. So the space is, the height, the distance, safety issues, and of course there are factors around safety and security, of course, in this day and age that also come into play.
So I got to tell you, Kevin, Eric has an ulterior motive for asking the question about who pilots these things. Eric really wants to pilot one.
Wow.
Okay. And ideally he would like to fly one around like Iron Man.
Yeah.
So
he's not wrong. He's not wrong.
Yeah. Yeah, it really is exciting. I could go on and on about it. I know we don't have a whole lot of time, but there's been some very interesting work and demonstration projects, again, by the group we work with, To the Edge drone stuff. And I can send you the references for all this. They've done a lot of nice demonstration projects in indigenous or First Nations reservations, and I think even up towards Michigan. So, again, to boost access to emergency medical services and, other things about using these to deliver medical issues, medical supplies, emergency medical services, situations, food, vaccines. These have been tested in some of the reservations, in various parts of the country, which is a huge opportunity to really help out, again, overcoming these long distance geographic barriers, particularly when, people don't want to waste time driving 4 or 6 hours for basic, needs.
So you bring up the point right there, right? Is the issue of range, which of course we're sharing organs across longer distances and more frequently than we ever have. What do you think the possibilities are for using these for national organ allocation? Is it possible to use these to get organs themselves? If you were allocating an organ in Texas, to Washington, would that be feasible in the future, or is there a shorter range for these?
Yeah, that's a really important question. I think it's going to depend, this will go in stages in my view, but just like, let's say, an example of machine perfusion in this day and age, so many things are hybridized. I mean, people are so creative with the goal of improving, more volume, but also with good outcomes, right? So it's not, in this day and age, it's rarely just one thing. It's multiple things, right? So like back to base preservation, multiple modality, not just on ice in a box going a long distance. It's, pump, all kinds of different ideas, particularly with extrarenal organs. But at any rate, so the drone could be used to move from a hospital in the middle of nowhere to a major hub. And then at that hub, it goes on an aircraft for better timing to go the longer distance, let's say to Washington. Um, and so those, single-use long-distance flights, we haven't really conceptualized that yet, but certainly in areas, let's say, the geography is huge. Let's say from West Texas to Tucson, or, that's big distance, or, into Albuquerque. Big distance, not very well populated. So it's pretty safe. It's safer to conceptualize that, but it would be multimodality or multi-stages. And so the other thing that comes into play, you'll hear in the drone space, you'll hear first mile, last mile. So this is why it also has to be, somebody has to move the packaged organ to the designated, takeoff spot for the drone, and then it goes its distance. And then when it lands, somebody still needs to move it from the landing zone, into the transplant center. So monitoring for location and tracking is absolutely critical. It's already absolutely critical, as we all know. But that is where it is super, super important to be able to keep an eye on, on where things are.
So I hate this topic, but it's a necessary topic. I got to take it there. Let's
Sure.
talk about cost.
Sure.
Let's talk about cost. So, I mean, like, if you think of it, and I have never purchased like a military grade drone, so I got no idea. But now, like, if my husband knows this exists, like, he's going to be asking. So I'm very curious. So, I mean, you would think that this is not a plane, and it's not physical personnel in a car driving, or, so you would think that this has the potential to not only impact like timing and ease of service, but cost in a pretty major way. Like contracting planes, contracting helicopters, personnel to drive. These are all very expensive aspects of organ allocation and sample and organ movement. And they're hard on logistics. Logistically, they're very complicated. Does this ease that? Is the operational cost for these comparatively lower than some of the things that we're doing right now? Or have you found some kind of surprising roadblocks in those scenarios?
Well, so, like most innovation, it's got to diffuse. And so you will have cost savings by not having a human being, having to pilot, these types of aircraft. And initially, it's going to be more expensive, but as you scale this, it's all about volume. It's just like, organ transplant in a hospital. The more you do, the more cost effective and efficient you become. And so the idea is once you get this to scale it, the more you use it, the more the cost comes down per run, right? And I think that's in some of the other groups that have invested in these projects, that's the idea, because moving something 3 hours by drone is a hell of a lot cheaper than having 2 pilots in a King Air fly up someplace, pick up something, fly it back. I mean, that's $10,000, easy, right? So there will be cost savings on the front side. There won't be, but as this scales and you have more volume, and that's the key thing, is to have these, for example, could you run this sort of like in a space like Texas? Could you run it kind of like a bus route? Right? So there's a routine set of movement scheduled plus or minus 30 minutes through designated pickup points. And, this was something with the volume that we have of our cases in Texas and region in Oklahoma. I mean, we're so busy, our volumes are pretty high. If you had kind of a pre-scheduled pickup movement, that would start to bring down the overall cost because we could load on samples and so forth. And it's really going to also, just like everything else in organ donation, especially, it's impacted by geography. So place matters. So it's easy to talk about this, from a generalization perspective on the front side, but as you get further into this, you look at, geography. This would be more complicated, let's say in the Northeast, just because of the population and the airspace. and it would certainly be easier. Our notion is it's going to be easier in rural America. And then we also think that, there also is clearly actual funding coming and signals that there will be increasing funding around, loading this up into the concept of funding initiatives to overcome barriers to accessing healthcare in rural America.
So Kevin, one of the interesting things as we think about this, right? A drone taking off and landing somewhere else is the weather, right?
Mm-hmm.
I mean, how do these things handle flying in bad weather? And you wouldn't know anything about this in Texas, but what about cold temperatures?
Yeah, that's a great question. And so one of the uh, benefits, or one of the great things that has come out of this project, is in Lubbock at one of the old military bases, the old Reese Air Force Base, that now is a bona fide drone research center. And that's where they have the Wind Research Center already. And of course, wind and West Texas, they go hand in hand. And it does get very cold in West Texas when you look at just think about the latitude of the locations. I mean, it's equal with Oklahoma in many areas, with the panhandle and stuff. It gets very cold. So just like all aircraft, it's subject to, proper flight conditions. And so, heavy duty winds, any kind of rain, wind would affect that. And that is one of the downsides, just like it is with aircraft. You're subject to the impact of the weather.
Now I gotta follow up with that. When you say it gets very cold in Texas, I gotta
Well,
ask for some clarification. I'm
does.
from Michigan.
It does. I will back him up on that. Someday I will tell you the story of me almost getting stranded on the top of Guadalupe Peak because of a winter storm. Someday.
I know where that is.
All right.
Yeah.
Yep. Yeah.
And there's no cell coverage up there either.
No.
None. Nothing. No.
No.
Yeah, so cold, so cold. I mean, it's just, I always say in Texas, we have 4 seasons every day. And I mean, and that's sort of, it's an exaggeration, but in many ways it's not. It depends on where you are because the state is so huge. But it doesn't get Michigan cold very often. Let's just put it that way. I was laughing about your perspective is very different than mine is in Houston.
No, thank you so much for being with us, Kevin. I think there's a lot of advances being made, and thank you for shedding some light on all of the work that's being done there. And I would love the opportunity to have you come back as this continues to evolve as a technology, and see where we are and where we're going. So thank you very much.
Sure. Thank you, guys. Thank you. Great questions, and really honored to be here with you all. And we appreciate, all of us out in OPO land, appreciate all the work that you all do. I don't think you get enough thanks for what you all do. You kind of behind the scenes, making it happen for patients, and the work you all do, has been so dramatically important in improving outcomes. And yeah, I really appreciate what you guys do.
Thanks,
Thank
Kevin.
you, sir.
Welcome, everybody, to The Tea, the portion of our show where we answer listener questions. And the listener question for today is, I have trouble meeting my CE requirements every year. I'm so busy on the bench that I feel like I don't have many CE options. What CE options do I have that are perhaps easier to get or that I'm not thinking of? Thank you, anonymous listener, for this question. This is a good question. Gentlemen, what do you think? How do you encourage your people to go after CE? The bench is busy.
I know, right? Because it is like a very common problem. I think that, I feel like I face it myself, right? Like, where do you get your CEs from? So one, I think a good one to mention is OSHI has modules for CE on it, and they cover all kinds of fun topics. And I think that's a really good resource. Believe it or not, your very own podcast counts as CE credit. You have to fill out, I believe, a JOT form to get credit from listening to our podcast as well.
Yeah, and I would tack on to that that only half of your CE credits have to be directly related to the science of histocompatibility and immunogenetics. So a lot of the training that you probably already need to do for your job can also count as continuing education credits. Those are things like laboratory safety. It also includes things like learning a new assay. So if you're doing training for work, that also counts as continuing education credit. It can count if you are writing a new SOP for your job, something like that. So there are a lot of ways to get continuing education credits, and a lot of the details are on the ASHI website.
I feel like Jeremy knew so much about that. I was like, I had totally forgotten that you could use like the basic laboratory safety sort of stuff as CE. Well done, Mr. Sherrill.
You could also attend an ASHI annual meeting and knock out all of your continuing education credits in pretty much one shot. That's my favorite way to do it.
Yeah, I also encourage my technologists to be a part of our abstract work and our publication work, because those count also. So if you can find time, the bench is really busy, but if you are encouraged or you can find time in your lab to be a part of research initiatives that get published, that's great too. Awesome. Well, thank you guys. And don't forget, audience, if you need career advice or have a question about something happening in your lab, visit our podcast page at ashi-hla.org/page/ASHI podcast, or email us at info@ashi-hla.org with the TEA in the subject line.
Hey there, Coffee and Compatibility listeners. Do you have a technologist that you'd like to spotlight? Nominate them by sharing their story with us. Email us at info@ashi-hla.org for a chance to feature them in an upcoming episode of Coffee and Compatibility. Don't go anywhere. We'll be back in just a few moments to recap our thoughts on today's episode.
Welcome back, guys. I love today's episode. I think that Kevin and the OPOs that he's partnering with are doing amazing work. I mean, like, the OPOs are under so much pressure, but this is OPO innovation, right? Like, at its finest. It's so cool. It's so cool. I want to get my samples by drone.
So, I mean, come on. Look, right here. I mean, come on. Yes.
Yeah.
Just yes. All day, yes.
Yeah. Jeremy, do you want to get your samples by drone?
I want to get mine directly from Iron Man himself. That's what I want. I want them delivered.
Iron Man on a drone.
Can we?
Yeah. I think that they're doing such a great job of thinking through the complexities necessary to make this a reality, right? Like, they're not rushing to the end game of let's put a human organ that's being used for clinical transplantation and just zip it through the air, and figuring out all of the nitty gritty, super important details, like the whole train.
Yeah, flying around train routes.
Story. I was like, that's legit. Like, that's
serendipity and innovation. Yep. Yeah, I mean, it's cool. I will admit, like, so our OPO here in San Antonio, Texas Organ Sharing Alliance, which is about to merge with another OPO in Dallas. So that's like a whole different thing. They were part of this Project Matador, and they did like a presentation for us, and we got to go and we got to see one. These things are huge. They're like, well, I think they're huge. I think lots of things are huge. I'm a petite person, but they're bigger than me. They're like tiny aircraft. They're amazing to see. So, I mean, when you look at them, and there are, of course, like different flavors, right? Different models. Like, you could imagine like one that's a little bit smaller, lighter, less expensive to operate for samples, one that's a little beefier for maybe your kidney. And then maybe, like, you know, if you got your lung in a Paragonics chamber, like maybe that one takes like your super fancy, big, expensive drone, right? But just the possibilities just seem like so big and so bright. Because, you know, with nationwide sharing, everything's gotten so expensive. worth it. Saving people's lives is worth the cost 100%, but there are things that we can do and innovate to make it better. And I can't think of a better example than this.
Yeah. And I mean, I've heard of other drone technology as well, where the drones, where to travel long distances, they will actually like sit on a power line and use a tiny fraction of the electricity that flows through the overhead power lines for like 10 minutes, right? To like start to
Shut
recharge.
up.
Yeah.
You're
Right.
making
And so
that
they,
up.
I
That's
wish I
what you
was
do at
actually.
night. Eric,
Yeah,
you're going to find him laying on power lines in the night to recharge.
I got an arc reactor in my basement too. So they can draw power, right? And it allows them to go even further and further, right? And I mean, I think of the complexities and the ability to know that, right? Like, how often have we been like, when's the organ or when are my samples going to arrive in the lab, right? Like, nobody asks that question of an aircraft, right? Like, we know when they take off and we know when they land.
We don't know when they are able to taxi from the runway to the gate, though. We really don't know that.
That is spot on, Dr. Hitchman.
So
Spot
here,
on.
no worries.
It
Crazy, fantastic.
really is awesome.
Yeah, and it'll just build in its impact as the technology becomes better and more trusted and is integrated into more things, right? Even samples will be a game changer as you get the samples quicker, you can run the list quicker, especially with thoracic allocation. Thoracic allocation takes a long time. And so if you can get your results in, get your lists run earlier and start thoracic allocation, even that's a game changer. And then we'll get to the transporting organs part, which will be even more impactful. So
yeah, well, I think we should end it on this thought. New is exciting, but new is also hard. Do you think people will use it? Do you think people will be too scared to use it in the beginning?
Guess we'll have to find out.
yeah,
Till
I
next
think
time, guys.
Yeah.
Bye.